Our index screen showing a list of all the possible top stories is looking pretty good, and we're now ready to start moving on to the second screen of our application. Remember, the second screen is going to be a detail page of sorts. So if a user clicks on this story right here, we'll take them to the second screen where we will show them some information about that particular story. Or in particular, we'll show them a list of comments about it. Now, in order to change from this first screen over to the second one, we're going to have to learn a little bit about navigation in Flutter. Navigation is the process of changing from one distinct screen to another screen. Now, making use of navigation in Flutter is not the worst thing in the world, but we do have to learn about a couple of odds and ends around it, specifically when it comes to our application. All right, so first thing I want to remind you about, inside of our code editor, I'm going to open up my app.dart file. So inside of this app.dart file, we have our build method, and inside there, we are creating a material app. And on that material app, we have a name property of home right here. So anytime that we create a material app instance, we automatically get an object created for us called a navigator. So by just making this material app, we have already enabled navigation inside of our application. And all we have to do is make use of that navigation object that is created for us. So in order to understand this navigation object, we first need to understand a couple of the different properties that we can pass to the material app that will change how that navigator object behaves. So, quick diagram. Here we go. All right, so we've got our material app navigator right here. When the material app navigator decides to initially show some content on the screen, like when our application first loads up, that navigator is going to go through a couple of different steps, and it's going to ask itself a couple of different questions. First off, the material app is going to say, okay, when the material app was created, was a widget passed to the home property? And so if you look back over at our code right now, you'll notice that we are passing in a name parameter of home right here that is an instance of a widget. So when our material app first boots up, the navigator checks to see if this home property was provided. If it is, then the navigator automatically shows this screen on the screen of our device. Now, there are two things that we can do that will enable navigation to other screens inside of our application. Because of course, we probably don't want to just show that one home widget all the time for these more complicated applications. So the second question that the navigator asks itself, it checks to see if it has a map, and in this case, map right here is a data structure very similar to that cache map that we were using previously. So it's a collection of key value pairs. It checks to see if a map is assigned to the routes property on the material app. So in other words, did you and I pass in a routes property that is a map? If we did, then the navigator is going to start to look at that to figure out what information or what screen it needs to show on the device. And then finally, the last question that the material app navigator will ask, it will check to see if we passed a callback into the material app called onGenerateRoute. And so an example of that would be, here's our material app right here. Did we pass in something called onGenerateRoute? That is a callback function like so. Okay, so in total, a couple of different questions that the navigator asks itself. Now, technically, there is one other step on here where the navigator checks to see if we put in what is called a fallback route. In other words, this is a route that will be rendered if we ask to go to a screen that doesn't exist inside the application. You can kind of think of it as like a 404 page of sorts, but not super relevant for what you and I are doing, so I did not put it on this diagram. Okay, so let's take a quick break. We're going to come back to the next section, and we're going to go into greater detail on this map-based navigation right here and the onGenerate callback down here as well. So quick break, and I'll see you in just a minute. In the last section, we started talking about the different methods of navigation inside of a Flutter application. So again, anytime we make a material app, we automatically get an instance of this navigator thing for free. That navigator is then in charge of deciding what to show on the screen of our device. When the navigator decides to show something on the screen, it's going to ask three different questions in descending order. It's going to first check to see if we have a home widget. It'll then check to see if we have a routes map. And then finally, it'll check to see if it has an onGenerateRoute callback. And again, technically there's a fourth option down here, but we're not going to cover that one too closely. Okay, so in this section, we're going to investigate the routes method of navigation a little bit more closely. So in this routes table, as we refer to it, method of navigation, you and I as developers have to generate something called a routing table or a routing map. Again, a map is a data structure. You can think of it as a JavaScript object. It has keys that are strings and values that are things called page builder functions. And we'll talk about what a page builder is in a moment. With this routes table approach, it's our duty, like you and me as the developers, to take a look at all the different mockups that we're going to have, or all the different screens that we want to have for our application, and we assign a different route name to each one. So in our application, we've got our main screen over here, the kind of news list screen. We might assign a route name to this page of simply /. And then for the second screen, the details screen, we might assign a route name of /details. These route names are meant to somewhat emulate routes inside of traditional URLs that you would visit inside of a browser, like the browser I'm in right now. The route of / right here indicates that this would be kind of like the root route of our application. We then take all these route names and we stick them into this route table. And then for each route name, we generate this thing called a page builder. A page builder is not unlike the stream builder or the future builders that we've looked at previously. A page builder is essentially a widget that has a builder function. And anytime that builder function gets called, it's up to you and me to return the widget that we want to show on the screen. So for example, you and I, for the root route right here, would define a page builder that has a builder function that returns an instance of news list. And then for details, we would define a route name of /details, and then define a page builder that has a build function that returns an instance of news detail. Now, making use of this setup right here is definitely a very common way of setting up navigation inside of a Flutter application, but it has one very, very large shortcoming that you need to be very much aware of. So I want you to think about what you and I are trying to do inside of our application very quickly. All right? Well, you and I want to allow a user to tap on a screen, or a story like this one right here, and then go to a screen that shows information about that story that was tapped on. So in other words, depending on which item we tap on over here, we want to show different information on this screen. So the difficulty comes in the process of somehow passing information from this first screen right here over to the second screen. Because we need to communicate to the second screen, hey, story with ID 23 was just tapped on. So make sure that the story details page shows information about item 23. That is a big challenge with this routes table type setup. Here's why. When you and I define these different route names right here, we have to define very static route names. So we have to define names like just / or /details. And we cannot put in wildcards into those route names. So inside this route name that I added in right here, you'll see that I put in :ID. This is kind of a reference back to traditional web development, where :ID would be interpreted as kind of like a wildcard. And so if we wanted to go to a details page that shows details about the story with ID 23, in a traditional web application, you and I might decide to define a route of something like mynews.com/details/23. And so that 23 right there is meant to indicate that we want to go to the details page and see information about record 23. However, this type of route matching is not supported by Flutter right now inside this route name. So you and I do not have the ability to put in some type of wildcard like that. So essentially, the problem with this type of route navigation is that it just makes it a little bit challenging to pass information to this new screen that is being created. Now, it's certainly not impossible. We could definitely do this. We could make use of our block. Maybe we could put together another stream inside of our block that kind of records the story that we want to see on the story details page. So absolutely is possible to use this routes-based approach and navigate over to the second screen and show some very specific information on it, but it's not as easy as it could be. So for our application, rather than making use of this map-based routing or this route table option, we're going to instead make use of this other option called the onGenerateRoute callback. With onGenerateRoute, we can handle this type of situation where we want to do some navigation and pass over some very distinct information in a very easy and straightforward fashion. So let's take a quick pause. We'll come back to the next section, and we'll start to talk about how this onGenerateRoute callback navigation method works. In the last section, we spoke about map-based routing. With map-based routing, we can define these static route names. Anytime we visit one of these static route names, a page builder that you and I would put together would generate the actual widget that we want to show on the screen of our device. Now, in the last section, we spoke about how this is a very easy way to get started with navigation, but the downside is that it makes it just a little bit more challenging to communicate information from one screen to another. So rather than using this map-based routing, you and I are going to use an alternate solution called the onGenerateRoute callback. So with onGenerateRoute, you and I are going to pass a callback function to our material app right here, and that callback function will be used by the navigator to decide what to show on the screen. So let's take a look at a diagram and get a better idea of what's going on. So I want you to now imagine that you and I are looking at this screen right here, and we tap on this story that has the ID of 23. So of course, you and I want to go to this new screen over here and see information specifically about story 23. To do so, we would run a little bit of code to reference our navigator. Again, this navigator is created for us automatically when we create that material app. The navigator has a method assigned to it called pushNamed. PushNamed is a method that you can kind of think of as meaning add or navigate to a new named route inside of our application. When we call pushNamed, we'll pass in context, and again, this is that context argument that we see all over the place. And then as a second argument, this is what we really care about, we can pass in any arbitrary string that we want as the second argument to this. So when we call pushNamed and we pass in some arbitrary string right here, our onGenerate callback will be invoked. And let's see, onGenerateRoute, let's put the full name on there. onGenerateRoute will be called with a string of /23. So it will then be up to you and me to parse that route name, parse like the /23, we will extract the number 23 out of there, and that is the signal that we need to navigate over to the story details page and show information about the record with ID 23. So again, big difference between the map-based routing and onGenerate callback. First off, with a map, you have to define all of your routes ahead of time. With onGenerateRoute, you define a function that will be called with some string representing the new page that we want to navigate to. With the onGenerate callback, we have the ability to slightly more easily communicate information from one screen to another. Again, not impossible to do with the map-based routing. We absolutely could figure out a way to do this. Life is just a little bit easier with the onGenerateRoute callback method. In addition, this method of navigation right here is just a little bit more complicated. And so in the context of a course, I kind of prefer to show you the more complicated stuff because I really suspect you could figure out this map-based stuff once you've seen the more complicated version of navigation. All right, so that's it. That's what we're going to do. We're going to do this onGenerateRoute callback stuff. That's going to be called with some name parameter right here. We're going to parse that thing and pass that information over to some new story details screen. And then on that screen, we'll show information about that particular story. So quick break. We'll come back to the next section and get started with this. In the last couple of sections, we've had some discussion on navigation. So I know we've spoken about navigation several times. We've spoken about how this thing works, but just one quick review. Please entertain me for just 1 minute. Anytime we make a material app, that automatically creates our navigator. That navigator is in charge of deciding what to show on the screen of our device. In order to decide what to show, the navigator asks technically four, I'm just not showing it on this diagram right here, asks 3 questions. It first checks to see if it has a home name property. It then looks to see if it has a map under the routes property. And then finally, it checks to see if it has an onGenerateRoute callback. And then again, technically, there's a 4th option that's kind of like a fallback route. So now that we've got a better idea of what's going on here, we're going to try to implement navigation inside of our application using this onGenerateRoute callback strategy. So to get started, I'm going to flip on over to my code editor. I'm inside of my app.dart file. For our first implementation of navigation, we're going to keep things as simple and straightforward as possible. So to keep things straightforward and to get just a sense of how to use this onGenerateRoute callback, we're very temporarily not going to worry about showing the details screen. All I want to do right now, just to get a better sense of how navigation works, all I want to do is get this news list screen to show up on the screen of our device by using the onGenerateRoute callback method. So that's our very short-term goal. We're not going to use this home method of navigation anymore. We're going to use onGenerateRoute callback instead, and we're just going to try to always show exactly one screen, just the news list screen. Once we figure out that method, we'll then add in some complexity and put these story details in there as well. So with that in mind, let's get to it. So back inside of my app widget, I'm going to remove this home name property, and I'm going to replace it with onGenerateRoute. So this is supposed to be a function. The function is going to be called with an object of type route settings. And we usually refer to this argument as settings, like so. Now I'm going to put a comma in here on the opposite side of the function just to make sure that it doesn't collapse. Well, when we get stuff inside the function, then it won't collapse. So really quick about route settings right here. This is an object that you and I are going to use to decide what to show on the screen of our device. So remember, when I gave you a description of how onGenerateRoute works, I had said that at some point in time, we're going to call a function called pushNamed. As a second argument, we'll pass in something like /23. So that /23 string right there is taken and it gets wrapped up inside of the settings argument. So anytime that you and I try to initiate some navigation inside of our application, that action or that initialization of navigation, some information about it is going to be wrapped up inside this settings object. So very frequently, you and I are going to write code that's going to inspect this object and then decide what to show on the screen of our device. Now again, for right now, you and I only care about showing the news list. So just for this very first implementation, you and I are going to completely ignore route settings right here, because we are just trying to always show exactly one widget on the screen. Okay, so now inside of here, you might be thinking, oh yeah, we're just going to like return news list. Unfortunately, that is not the case. Returning something from this function is a little bit more involved than that. So before we write out the code that's going to show our news list on the screen, I want to give you one quick reminder. I'm going to flip on over to my news list widget right here, the screen news list. Inside of here, here's the build list method. And inside of here, we made use of that stream builder. We've also had this thing called a list view builder. Inside of our news list tile, we've had a future builder thing. And so you can kind of get the sense here that in the Flutter world, calling things builders and having them be widgets that produce another widget at some point in time in the future is a really popular strategy. Hopefully, that kind of makes sense. We've got stream builders, list builders, we've got future builders, there's other builders we got on top of that, builders everywhere. And so with navigation, it is no different. So from onGenerateRoute, we do not directly return an instance of the widget we want to show. Instead, we return a builder. Now this builder has a name of material page route. And inside of this material page route, as you might guess, we are going to define a name property called builder. So this is going to be a function that takes, you guessed it, context. And from this function, you and I are going to return the widget that we want to show on the screen of our device. So for you and me, we're going to return news list like so. Okay, so that's it. So this right here is basically the absolute simplest example we can put together with the onGenerate callback method of navigation. Even when we start adding in more complexity, it's not going to get much more complex than this. Essentially, when we decide to add in additional screens, all we're going to do is add in some if statements or switch statements that are going to inspect the settings object, and then depending upon what information the settings object holds, we will return a different material page route. The Navigator will then take this material page route, it'll call the builder function on it, and that builder function will be responsible for producing our widget. So now that we've got this code in place, I'm going to save this file, and then we're going to do a refresh of our simulator and make sure that the app is still working as we expect. So there's my refresh. I'll wait for this thing to kick in. And as you can see, everything still works just fine. Cool. So very simple with on generate route right here. Definitely worked out just fine. Let's take a quick break. In the next section, we're going to start to create our widget that's going to represent these story details. And then we will wire that thing up to our on generate route callback right here. So quick break and I'll see you in just a minute. In the last section, we wired up on generate route to our material app. At present, we've only got this one single screen inside of our application, which makes for not a very interesting example of on generate route. So in this section, we're going to start to create our second screen of story details. So back inside my code editor, I'm going to find my screens directory, and then inside there, I'm going to make a new file called newsdetail.dart. So I'll make that file. And then inside of here, we'll put in just a tiny bit of boilerplate just to get something to show up on the screen of our device. At present, we're not going to be too focused with actually implementing story details. For right now, all I really want to do is figure out how to navigate between these two screens. So back inside of newsdetail.dart, I'm going to import package flutter material.dart, as you might guess. I'll then make a class called newsdetail. That's going to extend our stateless widget. Inside this thing, I'll define a widget build method. And from there, I will return some text that says something like, I don't know, I'm a news detail. That'll work for now. All right, and small typo right here, I define the build method, need to make sure I receive the context argument as well. Okay, so that looks good. That's at least something to get started. So I'm now going to flip on over to my app.dart file. And inside of here at the very top, we're going to add in an import statement for that news detail. So at the top, I'll do import screens news detail.dart, like so. So now we need to somehow wire up that new screen to our onGenerateRoute method. But before we do, I want to first put together the actual navigation call that is going to get a user to navigate from this page over here to the story details. So essentially, I want to add this code in first. Because once we add in this code, then the purpose of that route settings object right here will start to become a little bit more obvious. So to add in that navigation step, we're going to try to think about exactly when we want to navigate our user from this screen over to this screen. That might sound like a silly thing to say, but really, when do we actually want to navigate a user over? Well, I think that chances are we want to navigate a user over when they actually tap one of these news story tile things. That's the distinct point in time at which we want to say, okay, time to navigate this user over. So to make sure that is the case, to make sure that we can run some code when a user taps on this thing, I'm going to flip back over to my code editor, and I'm going to find my newsListTile.dart file. So this is the widget that represents one of those very individual tiles. And it's when a user taps on this thing right here that I want to run some code that is going to attempt to navigate my user. So to add in an actual callback that will be invoked when a user taps on this thing, I'm going to go down inside of my build tile method right here, and I'm going to find the list tile widget. Now I want to very quickly flip back over to my browser, and I want to pull up the documentation for list tile. So back on docs.flutter.io. As usual, on the top right-hand side, I will look up list tile. And as you might guess, yep, we're looking for the constructor. So here's my constructor. And on the constructor, you'll notice that there is a name property of onTap. So this accepts a callback function that will be invoked anytime that the user taps on that very specific list tile. So in order to have the ability to run some code anytime that a user taps on the list tile, all we have to do is find the list tile constructor, and to it, I'm going to add on tap. That's going to be a name property. That will be a function, like so. So now if we wanted to, we could put a print statement on here that says something like, I don't know, how about item.id was tapped. Let's try testing that out really quickly just to make sure that the onTap callback works. So I'll do a quick refresh. Wait for the refresh to kick in. There we go. And now if I tap on this one, I see that ID blah, blah, blah was tapped. I could tap on all the others, and every time I see that different ID. So that's tap events, not the worst thing in the world, especially when we are making use of this list tile thing. But of course, we don't want to just print out a message. We want to do some actual navigation. So in order to navigate, this is why I really like Flutter, because they make some operations just so incredibly easy. So in order to navigate, we're going to get access to our navigator, and we're going to call that push named method. So navigator push named. Now, I got to be honest with you, with so many other mobile frameworks out there, getting access to your navigator object, because this idea of a navigator is certainly not unique to Flutter whatsoever, many other mobile frameworks, and I'm kind of looking over at React Native, make getting access to your navigator object rather challenging. Fortunately, in the Flutter world, not the case. You see, when we have that import statement for Flutter material.dart right here, the material file imports the navigator class into this file. Let's go look at the documentation on that navigator class very quickly. So again, over on docs.flutter, navigator, here's the navigator class. So this is the navigator class. Again, this is what our material app uses to decide what to show on the screen. On the right-hand side, actually, let's just go straight down. I'm going to scroll way down here. And under static methods, so remember, static methods are functions that we can call without creating an instance of this class. You'll notice that there is a function called push named. So this is a function that we can access without having to create an instance of the navigator, without having to pass down the navigator from some parent widget or anything crazy like that. All we have to do at any point and time inside of any of our widgets, as long as we import material.dart right here, that imports that navigator class. And so all we have to do inside of our build tile on tap method right here, we reference that class, and then we just directly call that static method on it of push named. That's it. That's it. No crazy passing around references or anything like that. Just call push named, and boom, we're going to navigate around. All right. Now, of course, we do have to pass in 2 arguments to this thing. So the 2 arguments we have to pass in are going to be our context, and we also have to pass in the name of the route that we want to navigate to. Now, inside of here, you'll notice that we don't really have any context variable around here. So in order to get some context inside of here, I am going to make sure that when we call build tile, I pass in the context as an argument. So build tile gets called from our future builder right up here. The builder, of course, has its own context. And so I'm going to pass that context as the first argument into build tile, like so. And then on the build tile method, I'm going to make sure that I receive that argument of context, and I will annotate its type as build context. So now our build tile method has access to context, and now we can take that context and pass it into push named. Then as a second argument, we're going to pass in some string that indicates what screen we want to navigate to. And so for you and me, in order to indicate where we want to navigate to on the details page, or what story we want to show inside of here, we're going to pass in a string of /23. Now, one thing I want to mention here, it is not strictly required to have the slash in there. We could just pass in the string of 23. That's totally an option. But at some point in time in the future, we might want to expand our application and have entirely different sets of screens. And maybe there's a different list screen and a different detail screen that we would want to put together inside the same application. And so the idea of using /23 right here anyways is because at some point in time, we might want to put in like items /23 to differentiate from like, I don't know, jobs 23 or comments 23 at some point in time in the future. And so we don't have to use that slash, but I'm just kind of future proofing here and making sure that we don't kind of shoot ourselves in the foot in some point in time in the future. So back at push named right here, as a second argument, I'm going to put in a string. I'm going to put a slash, and then we're going to use some string interpolation with our items ID. And of course, the item was already passed into this function. So I'll put my $, my curly braces, item.id, like so. And that's it. So now, anytime that we tap on an individual list tile, we're going to call push named, we pass in the context, and we specify and then the ID of the item that we want to see on the screen. So now all we have to do is go back over to our app.dart file. Whenever we call pushNamed, onGenerateRoute is going to be invoked with a settings object that has information about the route we're trying to show. And so we'll inspect that settings object and decide what different material page route we want to return. So quick break, and we'll take care of that in the next section. In the last section, we implemented our callback inside of the build tile method of our news list tile. Anytime someone taps on this thing, we'll call navigator.pushNamed. That's going to add in a new named route of / the item's ID. Because we are calling pushNamed, our onGenerateRoute method back over here is going to be invoked with a new settings object. And so now it's up to us to look at that settings object and then decide what we want to show on the screen. And one thing I want to make clear here is that when we return this material page route right here, we have to return a different material page route for each possible route that we want to show on the screen of our device. So when we are returning a material page route right here, this very specific material page route is customized specifically for news list. And so we need to create a second material page route in order to show the news details screen. So different material page routes for each different route you want to generate. All right. So inside of here, we're going to add in a little bit of logic to look at the settings object and then decide on what material page route we want to return. Now, when you look at this kind of method structure right here, you can see that we're already getting some kind of heavily nested code. And as we start to add in more code to decide what to show based on the settings object, it's just going to get even more and more nasty. So I'm going to suggest that rather than defining this onGenerateRoute function right here, maybe we extract it into a helper method on our app class. And so the only purpose of that is to make our code a little bit more legible. So to do so, I'm going to add in a new method on the class that I'm going to call routes. Routes is going to be called with that route settings object. So I'm going to say route settings, and it is supposed to return something of type route. I'll then take the body of onGenerateRoute, so everything we have right now, I'm going to cut that out, and I'm going to paste it into routes like so. And then of course I'm going to fix up my indentation a little bit. And then finally, rather than defining onGenerateRoute with this anonymous function right here, I'm going to delete that, and I will replace it with a reference to the routes method that we just put together. Okay, so now we've got a much easier to read little structure right here, and we can have this one function that is in charge of deciding what to show on the screen of our device. So it's now up to us to inspect this settings property right here, as settings argument, and decide which different material page route we want to show. So I'm going to add in an if statement up here. We're going to look at that settings object, and inside of settings, there's one very specific property that we care about. It is the name property. And so the name property right here, as you might guess, is going to be equal to whatever the second argument is when we call pushNamed. So if we call pushNamed with /23, then settings.name right here would be equal to /23. So it's up to you and me to now inspect settings.name and decide what to do based upon that value. Now in our case, we kind of have an either or navigation setup. We are essentially either at our root route of just /, or we are at a route that has the structure of /ID. So in this case, we've got a pretty easy setup here, a pretty easy check. We're just going to say if settings.name is equal to /, then we will return the material page route for news list. So I'm going to paste all that inside there like so. And then if settings.name is not equal to /, that must mean that we are trying to visit the news details screen, because that's the only other route we have inside of our application. So I will add on an else case. And inside of this else case, we are going to return a material page route that is going to generate our news details screen. So that's it. So as you might imagine, if you have more screens inside of your application that you want to show, you will have many other structures or many other routes inside of settings.name right here. Again, because we've got just / and just /ID, we can get away with some very straightforward logic. But inside of your own application, you might want to put together a little bit more complicated setup using a switch statement. And you could always look up the Dart docs on this. So a switch statement would be like settings.name, and then you do your different case statements inside of here like so. And then depending upon settings.name, you'll return a different material page route. But again, that's definitely overkill for what we are doing. Okay, so all we have to do now is make sure that we return a material page route for our news detail. So right here, I'm going to say return a material page route. This is going to have a builder property that gets called with some context. And then inside of there, we're going to return news detail. So of course, at some point in time, we are going to want to communicate that ID that is contained in that settings name over to the news detail. This is the point at which we communicate information from the settings, or basically whatever information we encoded inside that route name. That's the point at which we put it into news detail right here. So eventually, right above where we create the news detail, we're going to eventually have some code to extract the item ID from settings.name and pass into news detail. In general, this builder spot right here is a fantastic location to do some initialization or data fetching for news detail or whatever widget you're trying to show. So this builder method right here, great place to do some initialization. As a quick reminder, if we go back into our news list widget, and I know I'm kind of bouncing around right now, but really quickly, if we go back over into news list, remember we've got that code inside of here that we had said this is very bad, don't do this temporary. This was some initial data fetching that we needed to do to get our news list to work properly. And so a perfect place to relocate this initialization or this initial data fetching that this screen needs would be to move it into the material page route builder. Great place to put it would be right here. And that's exactly what we're going to do in a little bit. Okay, so we wrote a lot of code in this section, so let's take a quick break. We're going to come back to the next section. We're going to test out all this navigation stuff and make sure that what we have right now works, and then we'll focus on making sure that we can extract the ID of the item that we want to show on the screen from our settings object right here and communicate that down to the news detail. So quick break, and I'll see you in just a minute. In the last section, we created a new material page route specifically for our news detail widget. I now want to do a quick test inside of our simulator just to make sure that everything is working as we would expect. So if I now refresh this thing, anytime that we tap on an item, it should call our navigator with that push name method, and we should essentially transition over to that other screen. So I'm going to click on the top thing right here, and we see that we get that other text on the screen. Now, of course, the text is hideous, right? It's got the red with the yellow underline because we are only showing a text widget, and this is what you see by default if you show a text widget with nothing behind it. This is supposed to indicate an error of sorts, but without a doubt, we are successfully navigating over to the news detail. So we now need to do a little bit of work on the news detail. There's a lot of stuff we need to do. We need to make sure that the news detail properly shows a navigation app bar at the top so that a user can navigate back over to the previous screen. So we want an app bar like this up there that has that little kind of backwards arrow to go back over. In addition, we also need to make sure that we can communicate the ID of the item that we want to show from this settings object right here down into the news detail. So a lot of stuff to do. I think maybe first, let's start with making sure that the news detail screen itself is a little bit more presentable. So I'm going to flip on over to the news detail screen. And then inside of here, rather than showing this very plain text widget, we're going to replace it with a scaffold. Remember, a scaffold gives us all the very core elements that you expect to see on the screen of a normal application. It gives us the ability to put the app bar up top, we can put a body on, we can put on the floating action bar, all that very typical stuff. So inside my build method right here, I'm going to remove the text method, excuse me, the text object, and I will return a scaffold that's going to have an app bar. That's going to be an instance of app bar. I'll give this thing a title of text detail. And then underneath that, we'll assign our body. And I'm going to put that text back here as well. I'll just say I'm a details screen. Okay, so hopefully now that screen should be a little bit more presentable than how it is presently. So I'll do a quick refresh. Wait for the refresh. There we go. Now I should be able to tap on this first item right here, and that screen looks a lot better. So notice that just by using a scaffold and providing an app bar, a lot of navigation elements are coming together automatically for us. So for example, you'll see that this arrow right here is automatically put onto this app bar because the app bar has detected that it just was navigated to, or a route was pushed on. We can now click on that arrow and go back to the original list, and now we can tap on a different item and we still see that arrow presented. So by making use of this built-in navigator, along with the scaffold that has the app bar, a lot of these very common navigation patterns kind of just fall into place for us, and we don't have to do a bunch of extra configuration, which is really fantastic. Okay, so good progress. Let's take another quick break. We'll come back to the next section. We'll go back over to our app.dart file and make sure that we communicate that item ID from settings object right here down into the news detail. So quick break, and I'll see you in just a minute. In this section, we're going to start to focus on communicating the item ID that we want to show inside of our news detail from the navigator down into our news detail widget. So to do so, I'm going to flip back over to my app.dart file. I'm going to find the routes function, which gets called anytime that a navigation event occurs. I'm going to find that settings argument. Again, for the 5th time, I know I've repeated this many times, the ID that we care about is nested inside of settings right here on that name property. So inside of my builder method for the news detail, I'm going to clear out the comments that I have inside of here, and I'm going to replace it with some code that is going to extract that ID from that settings name property. So remember, settings.name is going to have something that looks like slash and then whatever ID. And so we essentially just need to remove that slash, and that's going to give us back the ID that we care about. So the code that we need to write for that will not be too bad. I'm going to look at settings.name, and I'm going to call a method on the string right here called replace first. With replace first, we pass in the argument of some character that we want to find inside that string. So I want to find a character of /, and I'm going to replace it with an empty string. So that essentially removes that /. So we go from something like / whatever to just the number. So that leaves us with the ID of the item that we want to show as a string. And of course, we probably don't want to work with it as a string because everything inside of our application currently treats IDs as though they were integers. So we need to somehow take that string that we get back and parse it into an integer. To do so, we can reference the int type and then write out .parse. So int.parse will take a string and attempt to retrieve an integer from that string. So I'm going to put a semicolon at the end, and then I will assign this to a variable that I will call, wrong equal sign, item ID, like so. And I'll collapse my sidebar so we can see that whole line. So now item ID right here is going to be an integer that holds the ID of the record that we want to show on the screen. So I'm now going to take that item ID and we'll pass it as a name parameter down into the news detail. Now, of course, we have not set up the news detail to accept any constructor arguments yet, so we'll need to make sure that we do that very quickly, but let's just get this thing inside of here for now. So I'm going to add on a name parameter of item ID, and that's going to be the item ID property that we just created. Okay, let's now flip over to our news detail. We'll make sure that the constructor expects to receive a name property of ID. So I'm going to go back over to my news detail file inside the screens directory. And then inside of news detail, I'm going to create a new instance variable that is marked as final because we are a stateless class here and we can only have variables that do not change inside of a stateless class. So I'm going to call this new variable item ID, and I'm going to annotate its type as being an integer like so. I'll then create my news detail constructor. So this is going to have curly braces, this dot item ID, like so. And then I think the last thing that we'll do here, I'm going to update the body of the scaffold to print out that item ID, just so we can make sure that it is showing up inside this widget as we would expect. So I'm going to replace the I'm a detail screen with $item ID. Remember, we still have to use the $sign right here because item ID is a integer. We're using the quotes here because it's an integer. We need to pass a string to the text element. Okay, ready to do a test, I think. I'll save this file. I will refresh my emulator. Wait for the refresh. There we go. So now I should be able to tap on this element and I'll see its ID on the screen right there. And as I tap on each additional element, I'll see a different ID. So this one is 305. If I go down here, I'll see 449. Perfect. Okay, so we're now able to communicate our ID down to the news detail, which means now we can use that ID to fetch the item that we care about and show some details about it on the screen, along with our big set of comments. So quick break, and we'll start fleshing out our news detail in the next section. We now have the ability to navigate from our news list screen over to the news detail screen. Anytime a user taps on this list item or any given list item, we transition over to the other screen, and we know about the ID of the item that we want to show on there as well. So we've got just about everything we need. All we have to do now is take that ID and actually go and find the item related to it. Now, one quick thing that I want to remind you about was that earlier on inside this application, we had said that we would have two separate blocks for each of these screens. So we'd have the stories block for handling everything showed on the news list, and we would have the comments block for handling everything shown on the story details. Again, we did not strictly have to make this decision. We went with this route, or we went with the two separate routes, just to give you a good example of how we would wire up multiple routes inside of our, multiple blocks inside of our application. So without further ado, let's flip back over to our code editor. We're going to start to implement the comments block so that we can take the ID that is passed to the screen and turn it into the story that we care about, along with all of its child comments. So I'm going to flip back over to my code editor. I'm going to first close out all the files that I have just to kind of clean things up. I'm then going to find my blocks directory, and inside there, we're going to create two new files, one for the comments block and one for the comments provider that is going to manage that new block as well. So inside blocks, I will create comments block.dart, and I will create comments provider.dart as well. So we'll first put together a little bit of scaffolding for the comments block just to create the class. Inside the comments block.dart file, I will create a class called comments block, like so. And we'll leave it like that for right now. We'll then flip back over to the provider file that we just created, and we'll put together all the boilerplate that we are always going to have inside of one of these providers. So inside of comments provider, at the very top, I'm going to import package Flutter material.dart. I'm then going to import the comments block that we just created. And remember, I'm also going to export the comments block from this thing as well, so that any other file inside of our application that imports the comments provider file will automatically know about the comments block type as well. Because if you're going to use the comments provider, chances are you need to know about the comments block type too. So I'll put export comments block.dart. Then inside of here, we'll do comments provider, which is going to be extending inherited widget. Again, we are using inherited widget so that we can look up our widget hierarchy and find the nearest comments provider at any point in time. This thing will have an instance variable of type comments block that we will refer to as the block inside of here. We'll define our constructor method that is going to initialize that block. So the constructor will be called with that key property and a widget that is the child to this thing. We'll then initialize the block. So get your colon in there to indicate that we want to do a little bit of initialization code inside of here as comments block. I'll put my comma in, And then after the comma on the next line down, we'll call the super constructor with the key and the child. So we're just passing those named arguments through. Now we have to define our two methods on here that are required by all inherited widgets. So we have to define bool update should notify. This will be called with a argument that we don't care about, and we're going to always return true. And I made a little verbal typo right there. I said two named functions that we always have to define. That's not true. The only name function we have to define is update should notify. The other function we're going to define is one that we choose to define, not required by an inherited widget. So the other function will be a static function that returns a comments block. We're going to call it of, and this thing will be called with a build context that we will refer to as context. And then inside there, we're going to do that very long function call. So we will return inside of a set of parentheses, we'll do context dot inherit from widget of exact type. And we're looking for a comments provider. And then we will tell Dart that whatever we get back from this thing right here, just so you know, you should treat it as though, so as a comments provider. And then after the outside set of parentheses on the comments provider that we return from that big long function call, we're going to pull off and only return the dot block property. So I'll put dot block, I'll get my semicolon in there, and then I'm going to immediately save the file to have this thing reformat itself, like so. Okay, so again, provider code, always going to be the same thing. Always the same stuff. You can really just copy paste it. We probably should have copy pasted, but in general, in a course, I don't like copy pasting because it's just so easy to accidentally forget to change, like, comments block right here to be something else. So this is looking pretty good. Let's take a quick break right here. We'll come back to the next section. We're going to wire up our comments provider to our app, and then we'll be able to start implementing some logic inside of the comments block. So quick break, and I'll see you in just a minute. In the last section, we put together our comments provider. We're now going to start to turn our attention to the comments block. In general, the comments block is going to have a lot of code inside of it that is very similar in nature to the stories block that we've been working on so far. However, there is one extremely important difference that you need to remember. So let's look at a couple diagrams so you understand how the comments block is going to be a little bit different than the stories one. Okay, so we looked at this diagram a long time ago. This was a listing of the different endpoints that we were going to access on the Hacker News API. So the first route that we made use of was the top stories route. Remember, we accessed this to get a list of all the different IDs of the top stories. Then the second endpoint that we made access to was the one to access a very individual item. So in all the code we've written so far, we accessed this endpoint right here in order to retrieve an item that represented a story. But now, we do not only want to represent a story, we want to represent stories, and we also want to represent comments. We're going to reuse the same item model class to represent these comments, so we don't have to create a separate model. We're going to work with the same one because all the properties are essentially the same. But it's how we fetch these comments that I want to remind you. And it's how we fetch these comments that are going to make our comments block a lot different than the stories one. So when we use this endpoint to fetch an individual story that we had seen inside of our IDs top IDs list up here, you'll recall that inside that item model that we got back, we had that kids property. And the kids property was a list of integers. And those list of integers represented the IDs of all the different comments that had been added on that story. But there was a little catch in there. A little catch. The catch was that the kids list on that initial story item that we fetched was only the very top level comments. The entire comment structure forms a tree of sorts. So in addition to all these kids on the initial story that we have to fetch, we have to fetch those kids, and then we have to recursively look at that comment that we fetch right here. We have to recursively look into its list of kids and fetch all of its kids as well. So every single time that we try to fetch one of these stories, we're going to make a tremendous number of requests, and they're all going to be recursive in nature, because we're going to try to essentially fetch the top level kids first. then fetch those kids, and then fetch those kids, and then kids, and then kids, and then kids, and it goes on and on and on. Before, when we were working with just our list of stories, it was a lot more straightforward because we had that entire list of top IDs. And so we just fed this list of top IDs to the list view, and we said, hey, just whenever one of these comes up, try to fetch it. And then we issued a very simple, very singular fetch request through our repository to fetch the very given ID. So now things are going to be a little bit different because we need to recursively fetch again and again and again and again with every comment that we load. So anyways, that's how things are going to be different. Now, in reality, even though it's different, it's largely going to involve a lot of the same code inside the comments block. Just one or two things very slightly are going to be different, even though it's going to be, a lot more data fetching. Let's look at a quick diagram that's going to give you a better idea of how we're going to lay out the comments block. All right, so here's our comments block. We're going to use a very similar structure to how we had just refactored the stories block. So when we start putting together the comments detail, we are going to eventually have a ton of stream builders again. Remember the issue that we just ran into with those multiple stream builders? When we have a stream builder listening to a stream, they each create a separate stream subscription, and all the transformers get implemented essentially on the other side of the stream subscription. And so we don't want to run into that situation again where we are trying to overfetch or just refetch all these items like 5 times or 20 times, or essentially however many times we have stream builders set up. So to avoid that, we're going to have this kind of two-tiered approach again, where we have an initial comments fetcher that is going to be responsible for fetching the initial very top level story that we're trying to look at, and then it's going to attempt to then recursively fetch all the comments underneath that. Now, just to be technical, that recursive fetching process is going to be implemented in our transformer. So we are going to have a very similar transformer to what we had last time, something like that scan stream transformer that tries to maintain a cache of all the items that we fetch. So we're going to maintain that cache inside this transformer, and then that cache is going to go to the comments output, and that eventually goes down to all these different stream builders. So that's the idea. Again, a lot of stuff is going to be very similar, not tremendously different. Just the one thing to be aware of here is that we have to remember about how we have to do this recursive nature of fetching. So let's take a quick break. We'll come back to the next section, and we're going to start wiring up that comments block. In the last section, we started talking about the overall design of our comments block. Again, we're going to have these two separate stream controllers. So I think that we can probably safely wire these both up to our comments block right now and at least get started on that front. So I'm going to flip back over to my code editor. I've got my comments block.dart file open. We've only created the class right now. Let's first get started by adding in a couple of import statements at the top. So I can almost guarantee you we're going to need that rxstart package. So we'll get rxstart from rxstart. I think that we're definitely going to need our item model class because inside of here we're going to eventually be working with item models at some point in time. So I will go up one directory into models and then get item model.dart. And then I think we're definitely going to need the repository because we still need to actually fetch items and we still want to access the API and use our database cache as well. So I'll go up to resources and I'll get my repository.dart. And then finally, I really expect that when we start to put in some type annotations inside this thing, something inside of here is probably going to be a future at some point. So I'm going to also import Dart async so that we can safely reference that future type. Okay, so I think that's all we're going to need for right now. You know what, one last thing, I'm just a little bit nitpicky. I like to put the Dart package imports at the top of the file or at the top of the list. So I'm just going to add that up at the top like so. Okay, so now inside of here, we're going to create two instance variables. One is going to be for our comments fetcher. The other is going to be for our comments output. The types that each of these are going to be working with are going to be identical to the types that we were working with before. So when someone wants to fetch a comment, they're going to put the ID of the comment that they want to fetch into the comments fetcher. The transformer is going to take that ID and then use it to add into a cache map that is going to be of type map of integers with future item models. And so that's going to be the type that the comments output is going to work with and eventually send down to all the stream builders. So inside the comments block, I'm going to do final comments fetcher, And notice how we're using the underscore right here, so that it is marked as a private variable that is not accessible outside this file. So this is going to be a publish subject that is of type integer. And then we'll do our comments output. That will be a behavior subject that is going to handle values of type map, where that map has keys of integers and values of futures that resolve with item models. I'll get my 3 closing greater thans, and then I'll put my parentheses on the very end. Now notice that the values inside of our cache map right here are going to be futures that resolve with item models. So we're going to take a very similar data loading approach to what we did on the news list screen, where we try to render every item as soon as it is available. When we start to render these different comment lists out on the screen, some of these pages are going to have a tremendous number of comments inside them. And so we're going to want to try to employ all these same strategies of fetching the bare minimum amount of data that we possibly can. Okay, so notice how these are both highlighted in green. It's because we are creating these different fields or these different sinks and we never close them. Let's take care of that right away by implementing a dispose method that we'll call comments fetcher.close, and we'll do comments output.close as well. And then I'm just going to put a couple new lines in there so we don't have to look at that thing just yet. All right, so we definitely know that we need the comments fetcher. We know we need the comments output. Those parts are not that bad. Now the next thing that we probably definitely need is going to be the ability to get access to the sink on the comments fetcher so we can add integers into this thing. And then we definitely are going to need access to the stream coming off this comments output as well. And so we're going to implement getters to get access to this thing's sink and a getter to get access to this thing's stream. Again, a lot of the code we're writing here is very similar to what we did back in our stories block a while ago. So back over here, I'll set up a section for my stream getters and for my sink getters. So for my stream, I'm going to define a getter that's going to return type observable. So this is going to be the stream that we're going to try to watch from all of our stream builders. And through the stream, we're going to have values of map, integer, future, item model flowing. So I will annotate the type as map int future item model 1, 2, 3. I'll then put down my get keyword, and then we're going to name the getter right here. We had previously named our getter inside of the other block we put together simply items. For this getter, to get a list or to get information about all the different comments that we're going to fetch, we can call this thing either comments, or what is going to be a little bit more obvious or a little bit more useful here would be to give it a name of item with comments, because that's technically what we're going to work with inside this block. We're going to initially try to fetch the top level story or the very item up here at the very top and all the comments underneath it. And so we're going to be using this kind of item with comments terminology right here several times throughout this block and throughout a couple of our different widgets instead, to indicate that in this case, we're not working with just a collection of like stories or just regular items. We're working with a collection or a single item that has all of its comments inside of here as well. So I'll put my arrow down, and I'm going to put a new line inside of here just so we get the entire line. We could write everything on one line, but once you save it, it'll refactor it to wrap the line anyway, so no big difference. So for the stream that we want to read, we want to return the stream from the comments output, because that's what our stream builder is going to expose to the outside world. So I'll do comments output dot stream, like so. And then we'll do something very similar for the sink. So we want to expose the comments fetcher sink add method to the outside world. So as we said several times now, that comments fetcher is going to receive values of integer. So when we return the function for the sink add method from that getter, it's going to be of type function. That's going to receive values of type integer. We'll put down our getter keyword. And then for the sink's name, we're going to again kind of fetch this or follow this terminology right here. We're going to call this fetch item with comments. So get the top level item and get all the comments underneath it. So then anytime someone references this getter, we're going to return the comments fetcher .sync.add, like so. Okay, so this looks pretty good. Now we've gone on a little bit long, so let's take a quick pause right here. We'll come back to the next section, and we're going to continue working on our comments block. So quick break, and I'll see you in just a minute. In the last section, we wired up our two big stream controllers inside the comments block, and we've exposed the stream on one and the sync on the other. So we are now starting to kind of implement this design right here, where we're going to take the ID of the item that we want to show on the detail page. We're going to feed it into the comments fetcher, and then our transformer is going to fetch that top level story and all the comments underneath it. And so that's one thing I want to make kind of clear here. Notice how this getter that we just created is called fetch item with comments. And so the idea here is that we're going to call this one single time from our widget with the ID of the story that we want to fetch. And then inside this comments block, we're going to fetch that top level story, like that story with the title of the story and all the stuff associated with it. And then we're going to recursively inside the block fetch all the comments associated with it. So whereas with the, if we open back up our stories block over here, we had fetch item right here that was being called by our list view builder many times for each individual story that we wanted to show on that list. But for the comments block, we're just calling fetch item with comments that one time for the entire screen. And then it's going to be up to all of our code inside of here to take that one ID and recursively fetch everything it needs. So just a very subtle difference. Okay, so this is where we're going to start to run into a little fun. This is where the recursive data fetching is going to come into play. We're going to first implement our constructor, and the constructor is going to set up this relationship between the comments fetcher, the transformer, and the comments output. And then we get to the fun part where we have to implement this transformer that's going to do all that recursive fetching for us. And that's where things are going to get pretty crazy. Okay, so constructor first. So I'll define my comments block constructor. And inside of here, remember we wrote out some code previously inside of our other block. It's going to be very similar inside of here. We want to take our comments fetcher, we want to transform its stream, and then pipe the result of all that to comments output. So inside the constructor, I'm going to reference comments fetcher's stream. I'm going to transform it. We've not yet created our transform, but I'm going to assume that we will eventually add a method to this thing called comments transformer. So when we call comments transformer right here, it's going to return the recursive transformer thing that we need to still implement. So we're going to take the stream, we're going to transform everything, and then we're going to take the cache map that comes out of this thing, and we're going to pipe it. So remember, that's the process of forwarding all the events from one stream to another. We're going to pipe all that stuff into the comments output stream controller. So I'm going to pipe into comments output. And I'm going to save this so it wraps the line for me like so. All right, so again, this is just setting up this relationship right here. We're going to get some integers coming in. They're going to flow into the transformer. Whatever the transformer produces, that gets piped into the comments output, and then all of our stream builders subscribe to the comments output. All right, so now we're going to start working on the comments transformer right here. So I'm going to define a method called comments transformer. This is going to return the same thing that we used previously, the scan stream transformer. And remember, the entire idea of this thing is that it's going to maintain some internal cache. That's why we are using the scan stream transformer. We're going to annotate the type of this thing. So when a value comes into the scan stream transformer, it's going to be an integer. And then when it leaves the transformer, it's going to leave as a map with keys of integer and values of future item model. Make sure you've got 3 greater than signs over here. And then we'll set up our parentheses. And inside of here is the first argument. We're going to pass in a function that is going to be executed anytime that a new data event comes into this transformer. So this is where we're going to do our recursive data fetching inside of here. And then as the second argument, we're going to initialize an empty map that is going to serve as our cache. So I'm going to create the empty map as integer future item model. And then I'll put down the curly braces, which is how we initialize an empty map. Our function right here, remember it gets 3 arguments assigned to it. The first is the cache, the thing that we're passing from function call to function call. The second argument is the integer ID, or the event that's coming through our comments fetcher stream right here and gets sent into the transformer. So that's the ID of the item that we need to fetch. And then finally, we get our index. Now again, we don't really care about the index. We might use it again just to print out the index and verify how many times the scan stream transformer is getting called, because again, we don't want to accidentally overfetch or anything like that. So in general, don't really need to worry about index, at least for this application. Okay, so now inside of here, this is where the fun comes. This is where we're going to do our recursive fetch. So for our recursive fetch, we're going to first start off by fetching this ID that gets passed in. So it's going to be very similar to code that we wrote previously. We're going to do cache at ID is repository.fetch ID. And excuse me, that should be underscore. Now you'll notice that repository is underlined because we have not yet initialized that as an instance variable on this class. Let's take care of that right now. I know that you probably want to finish this thing up really quickly, or this recursive transformer, but let's just make sure that we wire up the repository very quickly. Okay, so I'm going to go up to the top of the file. We've already imported repository right here. And so we could add in repository, which is going to be a new repository like so. So now back down inside the transformer, we're calling repository fetch, and I think that's a typo on my part. I think it's fetch item. Okay, that's better. So this right here is going to attempt to fetch that very particular item that just came in as an ID. It's then going to produce a future, because remember, this does not instantly fetch the item. It returns a future, and we are putting all those futures into our cache map. Now here's how we're going to do the recursive part. I'm going to reference the future that we just put into that map. So I'll say cache ID. And then I'm going to chain onto that future and get a notification of when that future has finished fetching its value. So to do so, I'm going to call dot then on it. So dot then right here, if you're familiar with JavaScript promises, the dot then function with Dart futures works identically. Whenever this future that we just assigned to this map right here resolves with its item model, we can chain on this dot then function, and we can pass in our own function like so. So then as soon as this future right here resolves with the item model that it was trying to fetch, this inner function right here will be invoked. And so this inner function right here is going to be called with the item model that we just fetched. So here's the item model. And now inside of here, we're going to look at that item model. We're going to look at its kids property, which is a list of integers. And we're going to say for each item inside there, for each ID inside that list of IDs of kids, we're going to iterate over that list. We're going to call each of those child IDs a kid ID. And then I'm going to use an abbreviated arrow function right here. Remember, an arrow function is just like a normal function, but it indicates that we're going to have just an omission of the curly braces. It also means that we implicitly return whatever statement we put inside of here, but we don't actually care about the return in this case. And then here's where things are interesting. So we get this kid ID. Now to recursively fetch this ID, we're going to reference that sync that we just defined right here, and we're going to pass this child ID into that sync. So let's say fetch item with comments, and I'll pass in the kid ID like so. Okay, so this is some pretty heavy duty code, so let's do a quick review. A value is going to come into our scan stream transformer function right here. It's going to be an ID of an initial story that we want to fetch. And so we can kind of imagine that it is like this ID of 10 right here. So that's going to come into our function. We're going to reach over to our repository. We're going to call fetch item and attempt to fetch that ID. From this chunk of code right here, we're going to get back a future. That future is going to, at some point in the future, resolve with our item model that we care about. We take that entire future, and we assign it to our cache map right here. We then reference back into that cache map, and we get the future that we just stuck in there. And we chain on a .then statement. So this inner function right here will be invoked whenever that future finally gets its item model from the repository. And so this inner function is called with that item that we finally got from the repository. So we're going to look at that items kids property, which again is a list of integers of all this thing's children, or all the comments that are directly underneath it. And for each of those IDs, so here's the kid ID right here, we're going to take that ID and pass it back into our sink. So the sink is going to receive this child ID. The child ID is going to flow into the scanStream transformer. The scanStream transformer is now going to attempt to fetch that child, and then it's going to recursively look at that child's kids and fetch each of them as well. So this is a very classic example of recursive data fetching right here. And it's all done by using our scanStream transformer. So as every subsequent child gets fetched, we take that result and we are just sticking it into that cache map, which then ends up being sent to our actual comment widget, or actual, what do we call it, the the detail screen. News detail. I'm at a loss of words. There's so much terminology floating around here. So that's pretty much it. Now, the one thing I want to point out here that is a little bit wonky is that it is technically a little bit non-standard to reach out of a transformer and get direct access back to the top level sink right here. So another way that we could have easily written this would have been to, without having to reference our own getter, which again is a little bit non-standard, we could have very easily rewritten the scanStream transformer ourselves by doing what we had done way previously of setting up a stream transformer.from handlers. Remember when we did that way previously and we put that handle data function on here? So we could have created our own cache map inside of here and done all of the recursive fetching inside of here, because this handle data function gets called with the event sync to allow this event to essentially travel on. So we could have definitely put all this stuff together from scratch without having to do this kind of funky step of accessing our own sync. So that's kind of not ideal, most ideal thing in the world, but honestly, the code here and here would have looked largely almost identical, and we're basically just saving ourselves a lot of work by reusing the scanStream transformer as opposed to trying to put the thing together from scratch. All right, so that's pretty much it. I think that's just about it for the comments block. So now we're going to move on to the next section. We're going to start making use of this block inside of our news detail widget. So quick break, and I'll see you in just a minute. In the last section, we finished up an initial implementation of our comments block. So we're now ready to make use of this thing inside of our application. One quick thing I want to remind you about is that we have created the comments provider, which is responsible for creating an instance of the comments block, but we haven't wired up the comments block to anything inside of our application yet. So the first thing I'm going to do is open up my app.dart file. Here it is right here. And inside of this, at the very top, I'm going to find where we created the other stories provider. And I'm going to create a new instance of our comments provider inside this thing. And I'm just going to nest it with the stories provider. So essentially, the two providers are going to kind of overlap each other. The first thing we need to do is import from the blocks directory the comments provider.dart file. And then inside the build method, I'm going to return comments provider. That's going to take a child, and the child is going to be this little bit right here. So I'm going to copy all that. I'll paste it in for the child. I'm going to put a comma in there like so. And I'm going to clean up the return statement. Cool. So we've now got our comments provider put together. Now the next thing that we're going to do is scroll on down a little bit and find the route builder that we had created for our news detail. So for the news detail, remember we had said that right here inside of our page route builder, this was a good location to do some initial data fetching. So right here would be a great location to attempt to do the initial fetch of that item ID. When we do that initial fetch, or when we pass that item ID, to our item with comments getter right here, or excuse me, fetch item with comments getter right here. So this is the sync. That's going to kick off the entire recursive data fetching process for us. So we only have to call fetch item with comments one time with the top level item ID for the story that we're trying to show. And that's going to fetch that story and all the comments underneath it. So right here, we're going to want to get access to the block that we just had created through the comments provider right here. Now, even though we are creating the comments provider right here, which technically creates that block for us, you might be thinking that we can kind of take the block directly off this thing and get access to it down here because, hey, they're in the same widget, right? They're in the same class. Well, we still want to, even though we're in the same class, we still want to use our provider to look at this context argument and use the providers of function to extract our block from it, even though we are in the same class. So inside the builder function, I'll say comments block is going to be comments provider of context like so. So that gets us access to our comments block. So I'll then take my comments block and I'm going to just directly call the items with, excuse me, not items with comments, it's fetch item with comments. I did that a second time. So that's our getter that returns the stream add function, and we're going to pass our item ID into there, like so. All right, so now by the time our news detail appears on the screen of our device, we'll have already started fetching the item or the top level news story and all the comments of the item that we are currently trying to show on the screen. So this looks pretty good. Let's take a brief pause right here. We'll come back to the next section and we'll continue inside of our news detail. In the last section, we finished up our material page route. Inside the material page route, we've got our comments block. Anytime that we're about to render the news detail on the screen, we go ahead and call our sync of fetch item with comments, passing in the item ID. And so that should kick off our entire recursive data fetching process. Now, before we test this out inside of our simulator, I'm going to flip back over to the comments block. So here's comments block right here. And I'm going to again flip on down to the comments transformer right here. And inside the comments transformer itself, I'm going to add in a print statement for our index argument. And remember, index right here, the argument index, records the number of times that our scan stream transformer gets called. And so this should record the number of times that we attempt to reach out to a repository and fetch an individual item ID. So let's now test this out inside of our emulator and see how we're doing. I'm going to do a quick refresh. And then in the list that pops up over here, I'm going to pick out the top post. You'll notice that it has 56 comments associated with it right now. So I'm going to click into this, and I'll see some print statements start to appear on the right-hand side. And it goes all the way up to 61. That means that our comments transformer right here was invoked, well, not precisely the comments transformer method, but the scan stream transformer got invoked a total of 61 times. So we fetched a total of 61 items from our repository, each one of those reflecting one individual comment. Now, something you might feel is a little bit interesting here. We just saw a total of 61 printed out right here, but according to this, there's only 56 comments associated with this story overall. So you might be curious why there's a little discrepancy. Depending on what story you are clicking on, you might see an equal number of comments and an equal number of print statements over here. It just kind of depends. The reason for the discrepancy depends upon whether or not some of these comments inside of here have been essentially deleted or marked as dead. So quick reminder, if we open up our item model file inside the models directory, remember that there's the deleted property and the dead property. So a comment can be marked as deleted or dead. If you do so, then the total number of comments over here is going to be decremented by 1. So dead and deleted comments are not reflected in the title or the total number of comments right here. But when we go to fetch all the comments, they are reflected in this list. So we do attempt to fetch comments that have been deleted or marked as dead. So in short, that's why we're seeing the discrepancy here in numbers. But more importantly, it appears that we are successfully retrieving all the comments associated with a given story. So those are now being loaded up into our cache map, which means we can now open up our news detail widget, and then we're going to start to write out some logic inside there to take that cached map of all those different comments and attempt to render them out on the screen. So from here on out, we're going to be doing a bunch of work inside of our new news detail screen. So let's take a quick break. We'll come back to the next section and start working on putting together some actual view level logic to represent this news detail. Quick break, and I'll see you in just a minute.